Hello there guys, welcome back to another epic and inexorable maths video. In this video we have a cool exponential equation here. We want to solve the equation 2 to the x plus 4 to the x equals 8 to the x. Okay, so how on earth will we do this? So there is a trick. If you've seen this trick before, then this will kind of naturally follow. But if you're looking at this and you're thinking, I'm blanking, I really don't know, let me show you a cool trick. And maybe in the future, you can map this trick onto other problems that you see. If you're learning something like A-level maths, if you're 16 to 18, doing some sort of maths course, this could be really, really helpful for you. Okay, and it's helpful for everyone to know about this. So the trick is that I'm talking about is that we should rewrite all of these numbers as powers of 2, because notice that they all are powers of 2. 4 is 2 squared and 8 is 2 cubed. So we can rewrite this as 2 to the x plus 2 squared to the x equals 2 cubed to the x, like that. Then we can rewrite this as 2 to the x plus 2 to the 2x equals 2 to the 3x. So this is a little bit better because all of the base numbers are the number 2. That's nice, but it's still not that great. It's not that useful because we have this addition going on here. If they were timesing, it would be nice, but there's not really a way to simplify this. So the trick is, again, to kind of spot this. It's not too obvious, but what you have to do is put this thing back into brackets, but the other way around. So 2 to the x plus, and then what I'm going to do is I'm going to write 2 to the 2x, not as 2 squared to the x, but as 2 to the x squared, okay? Which you can do, and that's equal to 2 to the x cubed by the same reasoning. Now, you can see here that this is basically a cubic equation in terms of 2 to the x. So if I come over here, if I let u equal 2 to the x, let u equal 2 to the x, then my equation is u plus u squared equals u cubed. Okay, hopefully that makes sense. Now, it's very tempting, potentially, to divide both sides by u. We can or can't do that. What do you think? If we divide everything by u, we're basically dividing everything by 2 to the x. Now, in maths, when you divide both sides by something that has an unknown in it, basically something that has an unknown value, like 2 to the x, well, we don't know what x is. You have to be careful that you're not dividing both sides by 0. So is there ever a case when u, or 2 to the x, could equal the number 0? Well, actually, there isn't. So we can divide both sides by u, but you have to be careful because most of the time you cannot divide both sides of an equation by an unknown variable. Okay, and that's because if it is equal to 0, then you're deleting that solution. It won't come up in your answer. But we know that 2 to the x, or u, cannot be 0 because 2 to the x equals 0 has no solutions. There's no number that you can raise 2 to the power of to make 0. That's why it's okay. So dividing everything by u, we have 1 plus u equals u squared. And now this is a quadratic equation. So we can rewrite it as u squared minus u minus 1 equals 0. And then we can use the quadratic formula. So 1 plus or minus the square root of minus 1 squared minus 4 times 1 times minus 1 all over 2 times 1. So u is 1 plus or minus the square root of, this is the number 1, and then this is the number 4, including the minus 4 times 1 times minus 1. So the discriminant, the inside of that square root is the number 5. And then it's all being divided by 2. Okay. Now, you might recognize this. Okay. In the case where this is the positive, 1 plus root 5 over 2, this is the golden ratio, okay? This is the golden ratio, really nice, really cool. But it's not too relevant. So that's u. Remember, we have 2 to the x is u. So 2 to the x is 1 plus or minus the square root of 5 over 2, okay? And we're looking for x. So I'm going to rewrite this as 2 separate equations. The first equation is that 2 to the x is 1 plus root 5 over 2. And the other one is that 2 to the x is equal to 1 minus the square root of 5 over 2. Okay, just splitting that into 2 cases there. Now, we have to be a bit careful because root 5 is bigger than the number 1, which means 1 minus root 5 is a negative number, which means 1 minus root 5 over 2 is a negative number. So we have that 2 to the x equals a negative number. Is that possible? No, it's not possible unless we deal with complex numbers, which we're just going to look at the real numbers. This is impossible. This has no solutions. No solutions. This one here. Because there is no number that you can raise 2 to the power of to make a negative number, no real number. Okay, so this is the one we care about. And to get x on its own, all we have to do is take log base 2 of both sides. And we will get that x is equal to log base 2 of 1 plus root 5 over 2. And that is the one and only real solution to the equation. So the solution to the equation 2 to the x plus 4 to the x equals 8 to the x is log base 2 of 1 plus root 5 over 2. And as I said a moment ago, this is a special number because it is the golden ratio. So if you like, we can say log base 2 of phi. Phi is the golden ratio, 1 plus root 5 over 2. So a rather golden result in my opinion. As always, guys, thank you so much for watching. I highly appreciate it, and I'll see you in the next video. Cheers.